Well, welcome back to the second chapter in our series of lectures on database management systems. The title of this one is Database System Concepts and Architecture, and this will be our first video in the series on this topic. The architecture of database management system packages has evolved from the early monolithic systems where the whole DBMS software package was one tightly integrated system to the modern database management system packages that are modular in design with a client-server architecture. This evolution mirrors the trends in computing, where large centralized mainframe computers are being replaced by hundreds of distributed workstations and personal computers, connected via communications networks to various types of server machines, web servers, database servers, file servers, application servers, and so on. In this set of videos, we present the terminology and the basic concepts that will be used throughout the series of lectures on databases. Our goals for this video are to learn about data models, schemas, and instances, to study three schema architecture and data independence and explain what that means, and we'll talk some about database languages and interfaces. In basic client-server database management system architecture, the system functionality is distributed between two types of modules. The client module is typically designed so that it will run on a user workstation or a personal computer. Typically, application programs and user interfaces that access the database run in the client module. Hence, the client module handles user interaction and provides user-friendly interfaces such as forms or menu-based GUIs. As we know, GUI stands for graphical user interfaces. In fact, your web browser could be a type of client with access to a database server. The other kind of module, called a server module, typically handles data storage and access, search, and other functions. Data abstraction generally refers to the suppression of details of data organization and storage, and the highlighting of essential features for an improved understanding of the data. Data abstraction does not refer to the details of how the data is organized or how it's stored. One of the main characteristics of the database approach is to support data abstraction so that different users can perceive data at their preferred level of detail. A data model, which is a collection of concepts that can be used to describe the structure of a database, provides the necessary means to achieve this data abstraction. By structure of the database, we mean the data types, the relationships, and the constraints that apply to the data. We're not concerned with where the data is written, how it's accessed, only a discussion of the data types, relationships, and constraints. Most data models also include a set of basic operations for specifying retrievals and updates on the data. In addition to the basic operations provided by the data model, it is becoming more common to include concepts in the data model to specify the dynamic aspect or behavior of a database application. This allows the database designer to specify a set of valid user-defined operations that are allowed on the database objects. An example of a user-defined operation could be a column entitled compute_GPA, which can be applied to a student object. The inclusion of concepts to describe behavior reflects a trend whereby the database design and software design activities are increasingly being combined into a single activity. Traditionally, specifying behavior is associated with software design. On the other hand, generic operations to insert, delete, modify, and retrieve any kind of object are often included in the basic data model operations. It looks like we're about to get into a somewhat lengthy discussion here. So why don't we go ahead and take a break, go out and check your knowledge. When you're ready, come on back and we will move on to the second segment. Since we've been talking about the data model, why don't we make the mystery word data model?